And let's start with number 47. And if you think I'm going to fit that all there, that's crazy. Let's zoom out a little bit. All right. So this problem, they give me a cost function. They say C of x is 1,000 plus 35x minus 0.01x squared. What are we producing here, guys? Coats, okay. Sounds like a good thing to produce on a day like today. I don't know about a raincoat, but a coat. All right, and so this is the cost of producing anywhere between 0 and 300 coats. And the cost is given in, is that dollars or thousands, or what is it?
Dollars.
Just dollars, okay. Because some of the other ones have been thousands. I want to make sure I know what I'm talking about. All right. Hey, if I asked you what are the fixed costs, I'd say $1,000. You're going to pay no matter what. And then this has to do with, well, why do we add 35? Maybe the materials cost $35 a coat, right? But then why do I subtract some things? Well, because when you buy in bulk, right, when you do things in bulk, sometimes there's some savings. And that's what this is representing, this term. Just so you to kind of know what's going on. But anyways, part A says, determine what?
Average rate of change.
Average rate of change. I'll just shorten that, call it AROC. As production increases from 100 to 150? Yep. Let me ask you guys, I did problems last time talking about the slope of a tangent line and the slope of a secant line. You guys remember which one's which? A secant line intersects the curve in how many points? 2. Is this one a secant line problem or a tangent line problem? This is a secant line problem. I basically have 2 points. And by the way, if I were to graph this, what shape would I have? That's a parabola. Although it might not look like one, because that's a really small number in front of x squared. It is a parabola opening downward. But, well, I'm going to pull out the calculator and take a look. So here I go. Calculator out. And let me go to the y equals screen and type that cost function in. So I get, let's see, 1,000 plus 35x. And then minus 0.01 x squared. All right, so there it is. Oh, I got to be careful. If I just hit graph, it's not going to do anything for me here. I really want to start thinking about the window. Now, they tell me what to do for the x's, right? What should I put?
0 to 300.
Sure. 0, 300. So we can make up to 300 raincoats, and this model applies. I'm going to put a mark every 100 so I can kind of see what's happening on the picture. Now, what about Y-min and Y-max? Well, I'm going to put down 0 for Y-min, even though I know what are my startup costs? 1,000. And now you're kind of guessing. How many thousands do you think it's going to be? Well, it's 35 a coat. You figure every 3 coats is like $100. And we can make 300 coats. Why don't I put 100, 10,000 for my Y-max? You see how I did that? I tried to explain how I got 10,000. I was figuring, what would it cost if you made 300 coats? Well, it's going to cost another 10,000. And then the scale, why don't we put a mark every 1,000? Again, that doesn't matter so much. And now I'm ready. And if it doesn't look good, I'll adjust the window. But let's see what happens. My graph. Oh, good. I can see it. I'm happy. Well, I don't know if I could see the end. But that's okay. I can still do what I need to do. Does it look like a parabola? Opening downward?
Like
It
a
is.
line.
What's that?
Kind of like a line.
It looks more like a line, doesn't it?
Mm-hmm.
It's a slight downward curve. Very slight. Matter of fact, when I compute my average rate of change, I think it's going to be very close to our instantaneous rate of change here. In other words, let me come here for a minute and draw my picture. I'm looking at the graph and I'm seeing that it goes from, well, 0, 1,000. I know that the cost of no coats is 1,000. And it's increasing. I'm not sure where it's increasing to yet. Is that too small for the back row? I'd say yes. Let's try to zoom in a little. Can you see? Okay. Jessica gives me that nod, makes me feel better. Okay. So, what happens? We're supposed to figure out basically what happens when I make 100 coats, 100 comma whatever. And then I'm going to want to know what happens when I make 150 coats. How much does that cost? And then I'll use those values, right? So I better determine this. Let's see. I would compute C of 100. So let me hit second, calculate a value. Again, could I do it by hand? Sure. I could plug 100 in for X into the function, but I may as well do it. What do you got there? Crystal, you got a better view than me.
4,400.
4,400. Okay. And what about if I put in 150? Let's try that.
6025.
6025. Okay. Guys with me? You understand what I'm really computing. When I'm computing the average rate of change, now the book says this: f of x plus h minus f of x over h. But what I'm really computing is the slope, right? H is what here? Delta x is another way to say it. And what number is it? It's 50, because it's 150 minus 100. Right? Question, Jamal?
I'm not getting 4,400 on my calculator.
Oh. Crystal? Anyone else get 4,400 like I did?
I got that.
You got it? So it must be a calculator thing.
Done in there right.
You have 0.01, but you don't have x squared. You have squared.
Oh, thank you.
So, but anyways, you get this. We have what h is. So for this problem, I could really say that what I'm doing. Oh, and I guess here's the other question: is what is my x value? 100, right? Because what you're going to do is f of 100 plus 50 minus f of 100 all over that 50. Okay? In other words, f of 150 minus f of 100 all over 50. And that's the red numbers that I wrote there. It's 6025 minus 4,400. Oh, wait, you can't see that. I'll put it here. 6025 minus 4,400 all over 50. And so, I can get what that is. 1575, right? Get out of here. 1625 over 50, right? And so, I'm getting 32.5. Is that right? So 32.5. What are the units? Dollars is the numerator. Coat. So what's it mean? If I interpret it, it means on the average, increasing production costs an extra $32.50 per coat. So you see, this can be used to figure out, hey, do you want to increase production or not? If we're going to increase another 50 coats, well, we're going to be paying an extra $32.50 per coat. And then you got to ask, what are you selling them for? If you're selling them for 25 bucks, don't do it. Right? If you're selling them for 40 bucks, maybe you're going to turn a profit. You guys follow?
Mm-hmm.
Now, part B is asking about instantaneous rate of change. Let me zoom out a little bit and talk about part B. Oh, and this has to be over here for you guys to see that. That's a problem. Learning. Okay, so part B. Yeah, you won't even see that if it's in there. I've got to put it. Okay. Thanks for being patient. Okay, here we go. Part B. So it says approximate IROC, the instantaneous rate of change when the production level is 200 coats. Well, that's X, the number of coats, right? So here my X has changed. Up there, X was 100 and the H was 50. So my instantaneous rate of change, well, I still do f of x plus h minus f of x all over h. But now I'm also going to take the limit as what happens?
Approaches 0.
As what approaches 0?
H.
As h approaches 0. Remember what h is. H on the picture above was 50. It was the distance along the x-axis from here to here. I want to shrink that, because if I shrink that, instead of having a secant line, I get more and more like a tangent line.
Bless you.
So on the picture, here's 200. But I don't want a secant line. I want to shrink it until I get a tangent line. And I'm looking at this, and I'm thinking that IROC is going to be smaller than the AROC I just computed. It doesn't look as steep to me. All right, now we'll see. So we're going to go ahead and compute. Limit as h goes to 0. So what I really want here, I know that x is 200. So this is the limit as h approaches 0 of f of 200 plus h minus f of 200 all over h. Okay? Now, if I want to write out what that equals, I'm going to need a bigger bar, a bigger fraction bar. Again, it's the limit as h goes to 0. I can put the h down here. That's no problem. Where it says f of 200, I should write down how you do that. I've been doing it on the calculator, and I can do that. But there comes a point where you want to see it mathematically as well, algebraically. So when I say I'm subtracting f of 200, you know what I'm really doing? I'm subtracting 1,000 plus 35 times 200 minus 0.01 times 200 squared. Does that make sense to you guys? That's what goes there. What goes here? Well, what goes here is f of 200 plus h. So that's 1,000 plus 35 times 200 plus h, and then minus 0.01 200 plus h squared. All right? And this is where it gets a little bit nasty, right? Because I'd like to compute algebraically what this big thing is and then take the limit. Now, the book didn't say to do that in section 3. What the book does at this point, if you look at their example, is they start making a chart.
Yeah.
Okay? And they say, hey, let's pick an h value that's really small. So they make a chart. They say, what's h? Give me a small h value.
1.
1 is small. 1 coat. Right? Then what would the interval be? Well, remember that my x value is 200. So what's x plus h then? 201. Joe, question?
I think why don't you just do x, to get h, why don't you just do x, like 200 minus 300 minus 200?
I could do 300 minus 200, but if I do 300 minus 200,
I get 100.
what is h? H is 100, right? And that's a big H. Jamel said, let's take h equal to 1. Instead of doing 300 minus 200, I'm going to do 201 minus 200. Do you guys understand the difference? In other words, what we're going to compute, if we do this example, we're going to do, well, again, like you said, 201 minus 200, the denominator this time is 1, because the denominator is always h. Here I'm going to have f of 200, and here I'm going to have f of, I shouldn't say f, what should I say, guys? C, right? C of 200 and C of 201. Print is tough. You know, just so you can see what the difference is, guys. In black, when I'm going to take the limit, you know what that is really? That's the exact value. The exact value I'm going to get by taking a limit. What we're doing here with this chart, that gives me an approximate value. Now, is approximate value good enough for you guys? Maybe it is, right? I mean, how exact do I really want to be? That's going to vary from person to person, from application to application. Okay? But I want you to understand both. I'm going to do the approximate value that we were working on. And then on the next page, I'm going to show you how we do the exact value. It'll be worth our time. Okay, so for the approximate value, do we have this in our calculators already? I hope so. Yes, no? Let me see what I have. Oh yeah, that's the cost function, right? Yeah, that's it. Okay, so let me go back to the graph. And I need some things. What do I need? I need the y values for which x's? I need 201 and I need 200. So C of 201, Crystal's taking a break. Go ahead. What is it?
7630.
7630, okay. and now 200. Let me type that in. What do we got?
7,630.
Oh, that's easy. 7,600? Even I can do that.
630 should have a .99.
Oh, what's that mean, 0.99? It means it's about, how about I put 7631? Okay, because again, I said approximate, right? So 7631 minus 7,600 over 1, that's approximately 31. 31 what? Dollars per coat. So see, when the production level is higher, then you get a different value. It's about $31 per coat. Now, is it exactly 31 per coat? No, it's $30.99 per coat, right?
Was that all we had to do to get the technically to get the answer? Was this?
Yeah. That's all you had to do.
Oh, man.
But that's the
They're really quick.
that's the approximate answer. Well, wait a minute. What if I wanted a more accurate answer? Because you notice Christina said it wasn't 1. It was 7630.99, you said, right? Okay. If I wanted a more accurate answer, I would shrink 1 even more. Maybe make it a half or a fourth. Eventually, we want to take the limit as h approaches 0. Now, some of you are saying, hey, I'm fine with that approximation. That extra penny doesn't matter to me. I understand. When you guys buy gas, what's the price of gas?
329 and 9/10 of a penny.
$3.29. Does that 9/10 of a penny matter to you? No, it doesn't matter to me either. Does it matter to BP Oil?
Yes.
Why?
It's after $1 billion.
They sell so much of it that, yes, it matters. That's why they charge it. You don't even feel it, okay? It's going to matter in some situations, these little approximations, all right? So we want to be able to do it exactly as well. So here I go. Exact. I need the limit as h approaches 0. And what the heck was it? Oh, there it was. It was, wow, 1,000 plus 35 times 200 plus h minus 0.01, 200 plus h squared. This barely fits on the paper. Minus, and then there was this big crazy thing in green, right? It was 1,000 plus 35 times 200 minus 0.01 times 200 squared. All over what? H. Now remember I said all this stuff here was in green. I said that. And I'm going to tell you that all that stuff in green is going to go away algebraically. So don't start trying to figure out what it is yet. Don't do that yet. Matter of fact, I think the first thing we should work on is this. Could everyone figure out what 200 plus h squared is algebraically?
You're saying don't calculate that last portion?
Don't calculate anything else except for the 200 plus h squared. I'd like to know what that is. And so on the next line, let's write everything the same. Limit h goes to 0, 1,000. Oh, I will let you do one more thing. I could take that 35 and distribute it. But when I do, watch what I'm going to write. 35 times 200 plus 35h. Okay? Minus 0.01. And now I know when I square a binomial, I get a what? Trinomial, thank you. And so what do I get? I get 200 squared, whatever that is. At the end here, I'm going to get h squared, whatever that is. And I'm going to tell you that the middle term you get by doubling the product is 400h. If you don't believe me, I'll have to multiply that over on the side for you. Okay, and then the stuff at the end, like I said, I think all this is going to go away because it's minus 1,000, it's minus 35 times 200, and it's minus 0.01 times 200 squared. Do you see that all that red stuff's going to go away?
Yeah.
Where does it go away? Well, let's see. Here's the 1,000, right? Here's the 35 times 200. You guys see that? What about the other part?
It should be, isn't it plus 0.001 on the
Oh, right. This would be plus, because when you distribute the negative, that becomes a plus, which is good, because then when you distribute this negative, it's going to be a minus. You see that? This negative to there is going to correspond to that there. So a lot of stuff simplifies. Bless you.
Thank you.
So thank goodness. Now I can try and clean that up. So we get the limit as h approaches 0. What's left? I'll do the denominator. All right, you guys do the numerator. Well, what do I write? 35h where am I? 35h is still there. A lot of the stuff's going away. I'm going to have minus 0.01. By the way, did anyone figure out 200 squared? Isn't that
40,000.
40,000, right? And we're also going to have minus 0.01 times 400h. But we're not going to have the last one, because the last one disappeared with everything else. Oh, wait a minute. That's not true. The first one disappears with everyone else. That's the one that goes. The last one is there. So what should I write? I should write minus 0.01 h squared. That's what I should write. Sorry about that. Got it? Okay, now what? Well, we're going to compute a limit as h goes to 0 eventually. What would happen if I plugged in a 0 for h right now? You get 0 over 0. We have hope. Maybe we can actually do something here. So I'm going to factor out an h. I would get 35 minus, now let's see, 0.01 times 400, that's just 4, minus, and this would be 0.01 h, because I took one of the h's out, all over h.
How did you get 4?
Well, 400 times 0.01 is 4, and I factored out one of the h's, right? So notice that this h, and this h, we factored one of them out. Now these h's are going to cancel. So I have the limit as h approaches 0 of, it looks to me like it's 31 minus 0.01 h. Actually, remember what Christina said the answer was when h was 1? It was $31 minus a penny. But what's happening when we send h to 0? This equals 31 minus 0, which is $31. $31 per coat. You see that? So this idea of instantaneous rate of change being a limit is something we're going to have to get used to. You're also going to need a lot of paper, right? I mean, that's one thing we're learning.
So, for,
Yeah, Jamel.
so technically, what we first did with the 1, that
Approximate.
would have been good for the answer.
For last lesson, sure.
Okay.
Because you would have got $30.99. Close enough, right? But, and in answering a question like this, of course. But what I thought I would also show you is that this is what I'm learning in Section 4, is how to do it exactly.
Okay. So Section 4 is doing it exactly. The Section 1 was doing it
Approximately, that's right. Matt?
Would you recommend always having that completely, like, write all that out, or instead of doing?
Oh, you want a shortcut?
No, that was a long way.
That's the long cut.
Yeah.
Yeah. How do we do it the short way?
Oh, there is a short.
Oh, yeah, thankfully. There's a lot. I love shortcuts. And there are lots of shortcuts. I mean, remember you guys asked me about that square root problem I didn't want to show you? You want to know why I didn't want to show you? It takes a long time. I'm going to show you now. We're ready for it. Actually, if you have your book, this problem is on page 108. And one of the reasons I didn't want to show you then is you didn't know what you were doing, but now you do. Watch. Okay. Part A says, evaluate and simplify f of 1 plus h. You guys are good at that now. Before you were, eh. Part B says, evaluate the, hey, doesn't that look familiar? What is that?
Slope of the tangent.
Yeah.
Yes. And is it AROC or IROC?
IROC.
That's IROC. You didn't know that back then. I didn't want to cover it. But now I do. You guys asked me about problem 71, and I blatantly refused to do it that day. But I'm ready now, okay? We're going to compute IROC for the square root function. By the way, do you guys know what the graph of the square root function looks like? Then use your calculator. Come on. Got to know this stuff. So let's see. Y equals, clear it out. I hit second x squared key to get the square root. I put in an x. I close parentheses. And before I graph, I better change my window. I'm going to press zoom standard. This choice 6 will give me just the standard graph. Hey, there it is. Hey, you know what's weird about the graph? Why aren't there anything on the left side of the screen? You can't take a square root of a negative number. We like to keep it real. Okay, in this
What did I
class?
miss?
Well, we're doing number 71 on page 108. So I'm about to do that. And I'm going to have to zoom out so you can see what we're doing. But basically, the square root function is a sideways parabola because it's an inverse of that. So 71, f of x is the square root of x. And my picture, you guys, looks like this. It goes through the point 1, 1. Oh, can you give me another point that it goes through? Well, 0, 0. The square root of 0 is 0. Do you guys know any other perfect squares? Okay, 4. So if I were to graph that, here is the point 4, 2. So I could draw, for example, this red line would be an average rate of change. But I'm trying to get this green line. That's what I'm really getting, is the IROC. You didn't know it back then. You were just computing a limit. You had no idea. Okay? So that's the slope I'm looking for, that green line. That's the answer. So let's compute what it is. So how do I do it? It says we should take limit as h approaches 0 of f of 1 plus h, because x is 1, minus f of 1 all over h. So let's see what I get. That's the limit as h approaches 0. Well, I always put the h in first. And then you know what you really have when it says f of 1 plus h? That's the square root of 1 plus h, right? Minus the square root of 1. What's the square root of 1? 1, right? So really what I have so far is the limit as h approaches 0, square root of 1 plus h minus 1 all over h. If you were to plug in 0 right now, what would you get? 0 where? Both. That means we have hope. Maybe we can do something. Actually, what Matt asked me, I remember, he said, hey, can you tell me how to factor this? And my answer is basically no. It's not factoring that I need to do. But I can do some algebra here. But see, I know why you guys didn't think of it. How many of you had an algebra teacher that told you you don't really want radicals in the denominator? Did you ever have an algebra teacher tell you that? They lied. I mean, here I have the radical in the numerator, right? I'm going to do something. I'm going to get it out of the numerator. And when I do, good things happen.
Conjugate.
What's that? Conjugate. Yeah, the conjugate. What is the conjugate? Go ahead.
You change the sign.
Yep.
Plus, and you divide it.
So you take, right, you take the same exact thing, but change the sign to plus. We're going to multiply by the square root of 1 plus h plus 1. That's right. It's Edgar? No. Edgar? No, what's the name? Leo? Over square root of 1 plus h plus 1. That's exactly right.
Yeah, I thought you usually did that to get it, to the other.
Right. Well, shows what they know. I mean, why? Why do I care whether it's in the numerator or denominator? I have a calculator. I don't care. All right, here I go. So anyways, I'm going to multiply this out and see what I get. Well, my denominator, let's leave exactly the same. Let's write in the denominator h times the square root of 1 plus h plus 1. That's fine. The numerator, good things happen. I mean, if you multiply this out, first thing you're going to do, what's the square root of 1 plus h times the square root of 1 plus h?
1 plus h.
Right, the square root goes away. Now, when you do this, if you do the outer term, you would get square root of 1 plus h, right? But then if you do the inner term, what happens? You get minus. That's why conjugates work. The outer and the inner go away. So the only thing you really get in the numerator besides the 1 plus h is what? Careful. Minus 1. Minus 1 squared. It's a minus, right? And that's a good thing, because then what happens? I get the limit as h approaches 0. The only thing in the numerator now is h. And then in the denominator, I have h times the square root of 1 plus h plus 1 in parentheses. Did that help? Did that help?
Sure.
Why? What can I do now? Cancel the h's, right? So we cancel those h's. And now we have 1 over, and this is the square root of 1 plus h plus 1. Now, can we do it? If you put a 0 in for h, does it work?
Yeah.
Yeah, this function's continuous at 0. So we get 1 over the square root of, well, 1 plus 1. What's the square root of 1? So what's the answer? All that work. And finally, but see, if I had done that the day you asked, you'd have got, okay, the answer's a half, big deal. But now we know what it means. What's it mean? The slope of the tangent line is a half. You guys see that? Tim says, yeah, sorry. Okay. Good. So I'm at 1203. Okay. What is it we just computed and we figured out it was a half? Slope of the tangent line where?
At x equals 1.
When x is 1. Do you guys know what the slope of the tangent line is when x equals 4? No, you don't. Could you do it?
Sure.
How long would it take?
20 minutes.
The rest of class. Okay, well, maybe. Could you guys do the slope of the tangent line when x is 9?
We could do all those by just.
You want a shortcut.
Well, no, the derivative.
Right. The derivative is the shortcut.
Yeah.
Because if I'm going to keep giving you these problems, which I am, you're going to want not to have to do this big long thing every time. You're going to want to do it once and we're done.
Is that the derivative, though?
That's the derivative.
What we just got.
This is the derivative at a certain point. Remember, the derivative is really a function. Let me show you. And this is what section 4 is really about. So let's suppose I'm given that square root function, since I'm thinking about it. And I want to find the derivative. Okay. Now, I gave you notes on the derivative last time, but we haven't really done this for homework yet. So I'm going to remind you what this is. F prime of x is how I denote the function called the derivative. It's going to be a function that will give me the slope of the tangent line for any of those points. So here I go. F prime of x equals limit as h approaches 0, f of x plus h minus f of x all over h. I claim this is going to be no harder than what you just did. It's just that I don't have a number for h. For x. I put an x there. So watch. We're going to write limit as h approaches 0. Where it says f of x plus h, what am I going to write? Square root of x plus h. Where it says f of x, what am I going to write? You guys see it? That's square root of x. Put that over h. Right. We know the trick to compute this. We just saw it. I mean, there was nothing special about having the ones in there. I'm going to multiply by the conjugate. In other words, I'm going to multiply top and bottom by what?
Square root of x plus h plus square root of x.
Plus square root of x, that's right. So square root of x plus h plus the square root of x. There it is. So let's work out what that is. Let's see. We get limit as h approaches 0. I told you guys, don't worry about the denominator, just kind of leave it the way it is. H times the square root of x plus h plus the square root of x. There's that. Now what about the numerator? What are we going to get?
X plus h minus 1.
Yeah, we're going to get x plus h for sure, right? Because that's what happens, the square roots go away. The outer and the inner cancel. And then we get minus, what's the square root of x times the square root of x going to be? So it's just x, right? And that's a good thing. It's kind of like what happened last time. What's going to happen? Limit as h approaches 0. The only thing left in the numerator is h. What are we going to do next? What's that? Yeah. Did someone say, get the h out of here? Yes. In about 10 minutes. So it's going to be 1 in the numerator, and you get the square root of x plus h plus the square root of x in the denominator. Now can I take the limit as h approaches 0? Yeah. I will get 1 over the square root of x, because the h went to 0, plus the square root of x. Can you simplify that for me? 2 square root of x, right. So the answer, if I said, what's the derivative? You would tell me, oh, the derivative, f prime of x, is 1 over 2 square root of x. Done. Now, how does that help me? Well, remember, we had a square root function. It went through things like 1 comma 1. It went through things like 4 comma 2, right? And so if I asked you guys, what is the slope of this blue tangent line? Well, that's f prime of 1. Put a 1 in for x, and it'll tell you the slope. Because what's the square root of 1? Okay, so 1/2. That's what we got last time.
So now we could find the slope of any tangent line.
Any tangent line. Let me do the one at 4 here. If I want to find the slope of that line, it's not going to be as steep. How do we do it? We write down f prime of what? You always put the x value there, right? 4. How does the formula work, this derivative? We do 1 over what? 2 square root of 4. That equals 1 over 2 times 2. So what's the answer? So that is a slope of 1/4. And that actually looks right. It's not as steep as the other one was, 1/2. Guys follow? So that'll save a lot of time. And wait until Monday. On Monday when you guys get here, we're going to do a group work. We're going to start putting together derivatives and some nice shortcuts. And some of you I know have seen it before, and you'll be a lot happier yet.
No.
Okay?
Yes, no.
Do you have time after class today, Paul?
I do. I have time from now until 12:45. So you guys are welcome to stop by. Yes, please don't leave without turning in that homework. Pass it forward.